Okay, in the other video, I kind of explained what a binary number was. So if you haven't watched that, you might want to give it a shot. But now we're going to what we're going to do now, though, is we're going to take just regular numbers and convert them into binary numbers. And by regular numbers, I mean, base 10 numbers. Like all the numbers we're used to messing with. Okay, so just to get an idea, let's just take a real simple one. Let's just take the number 120. Okay, let's take that and convert that to binary. Okay, and what we're going to do is we're just going to divide this number in half, and every time there's a remainder, we're going to keep track of it. Just watch me, and you'll figure it out. It's pretty easy. So. And this is just a simple example. So we'll take 120 and we'll divide it by 2. Okay, that gives us 60. Okay, then we're going to take 60 and divide it by 2. That gives us 30. Then we're going to take 30 and divide it by 2. That gives us 15. So we'll take 15, divide that in half, and that's 7.5? 7.5? And now we're going to divide, we're not going to divide 7.5, but we're going to divide 7, okay? And that'll give us 2, is that going to be 3.5, I think? Then we'll take, and notice how we're just going down the line here. 3 divided by 2, that's 1.5. And then I think we get all the way down to 1 divided by 2 is just 1/2. Sometimes I mix up on the on what I mean here. But okay, first of all, notice all these little guys here. Let's look at the remainder. Okay, well there is no remainder here, is there? Okay, and there's no remainder here. There is there's no remainder here. There is one here. It's 1/2. Okay, so we'll put a 1 there, and every time there's a remainder, we'll just put a 1. Okay, and now it looks like we're starting to get somewhere. The only thing you got to remember after you do this is basically the start of the number, and this is the end. Okay, so at the end of the day. Okay, this right here is going to be 1111000. Okay, that's the binary representation of 120. And sometimes, when working on, we just write like a sub 2 or a sub 10. Okay, and if we were to go and take all these numbers and raise them to increasing powers of 2. We'd get 120 back if I did my arithmetic right here. I think I did. So, but that's basically how we do it. So let's just go ahead and do another. Let's do another example of binary conversion. Okay, and let's take a number like. Actually, let's take. This is kind of interesting. Let's take the number 32. Okay, and the reason is we've all heard of like 32-bit. 32-bit this, 32-bit that, maybe a game system, some type of processing deal. So something really interesting is going to happen here. Okay, we'll take we'll divide 32 in half, and we get 16. Then we'll divide 16 in half. We get 8, and so on. I mean, I'm not trying to be redundant here, but But you see this neat little deal here. We get 1 0 0 0 0 0. Okay, so this translates to almost looks like 100,000, doesn't it? And what's kind of cool is you'll see for every one of these powers of 2, because 32 is equal to 2 to the 5th power, okay? So, notice how there's 5 zeros here. So, if something was, 64 bits, well, that's just That's 2 to the 6, and 128, you know, we've seen like 128-bit encryption, I think, and things like that. You know, that's 2 to the 7th. So you just have you know, a 1 with 1, 2, 3, 4, 5, 6, and 1, you know. So check this out, just the regular number 2. Okay, we know that we're all used to. Well, if we do that, we get 1. So we get 1, 0. Okay, so, and this will happen every time. So I don't know, I mean, I just kind of threw that one in there. You know, I mean, I'm sure you guys, you know how to do long division by now, you know, which isn't too bad. But being that, you know, these powers of 2 make all these things up, when you see like, you know, 2, 4, 8, 16-bit, 32-bit, 64-bit, all those numbers, okay, are going to be, you know, they're going to look like 1, and then they're going to be followed by zeros every single time. Okay, so there's that. Furthermore, so what if we have something that's 8-bit? Okay, what's the largest number that this thing can represent? Okay, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you get, you know, 1 times 2 to the 0, 1 times 2 to the 1, 1 times 2 to the 2, and yada yada, and you end up with 255. So I'm kind of yammering right now, so you know how to convert them. I encourage you to play around with them. You know, kind of neat. So that's binary numbers for you. That's them, and that's you know, I'm just gonna cut the video off. Okay, so go have fun with binary numbers.